Okay, everybody, my name's Professor Science, and let's learn about science!
Audio Jungle. Audio Jungle.
Do better! We're trying to film a skit! Get... So this is a converging lens. This will converge the light rays to a single point on the opposite side of the lens. Here we have the first principal ray, which goes parallel to the axis, principal axis, and then refracts all the way to the principal focal point. Okay, go back, Chris. Go back there fast. Go. Here we have the second principal ray. This principal ray passes through the secondary focal point and then refracts parallel to a principal axis. Now we have the third principal ray. This passes straight through the optical center, all the way to the other side.
Swing your partner round and round, and then the night is going down.
This is a diverging lens. This diverges light rays to different points that grow further apart on the opposite side of the lens. Here we have the first principal ray. This will go parallel to the principal axis, but deviated refracted rays seem to stem from the principal focal point. Here he goes back to the principal focal point. Hey, get in position! Here we have the second principal ray. This incident ray points in direction of a secondary focal point, refracted ray parallel to a principal axis. Here we have the third principal ray, which passes through the optical center, just like that. Oh. Alright, boys, there's only one way we're gonna win this war, okay? We need to learn about how images are formed. Okay. Alright, there's only one way we can do this. Get out of here, Dipsy, okay? We have to learn the simple rules, okay? So we have our first one here. We got if I do, I die. It's the only way we can understand, okay? F, this one, this is the most important. This is the focal point, okay? This formula, that's how you find it. You get the inverse of the focal point. That's how you get this. This is where we're going to strike. To get there, this is the battle plan. We're going to find the distance of the object and the distance of the image, okay? Distance, object, and the image. You understand? You understand? It's the only way it's going to work, okay? We're going to have to take these two, add them together, put the inverse of both of them, boom! It's the only way we can do this.
Hi, did you know that total optical power is equal to the sum the optical power of each lens in the system? So that means if they give you a problem where you're trying to solve the optical power of a total system of different lenses, that means you gotta find the focal length of each lens, then change it into optical power. The more you know.
Man, I just don't understand the difference in focal points between the converging and the diverging lens. It's too hard.
Well, Billy, the difference between the focal point for the converging lens and the diverging lens is that the focal point, the principal one at least, is on the same side as the refracted rays for the converging lenses. But for the diverging lenses, the principal focal point is on the same side as the incident rays.
Wow, that is easy. Let's talk about applied geometric optics! This is a reflecting telescope!
The reflecting telescope uses mirrors to focus the light together. To achieve this, the type of mirror used is a parabolic mirror. The reflecting telescope has the light come from a distant object, and then these lights all reflect on the parabolic mirror and converge on the same point where the secondary mirror is conveniently located. This secondary mirror is placed at a 45-degree angle in relation to the primary mirror's principal axis, so that the light rays reflect into the eyepiece.
What a loser! What a loser! He forgot to say that there's an eyepiece, and inside that eyepiece there's a convex lens that produces a bigger image.
Almost spot on, okay? Now we have to do it again, but we're gonna change everything. Almost everything, okay? This is everything. Okay, this is how it's gonna play. Okay, we got magnification over here. This one is the big one. Okay, we got magnification. Okay, this is what this is, okay? We got I over O. Okay, this is the only way it's gonna play out. This also equals negative di over dou, okay? If we use these two together to get magnification, okay? See, the thing about the HI, it's not the distance anymore, okay? This one, this is the height, okay? This is the height of the image, okay? This one is the height of the object. If we get those two together, it'll give us the distance and the object, but the negative, okay? And if we put those together, we get the magnification. Do you understand? You gotta get the magnification! Let's go!
If I lay here, if I just lay here, would you lie with me and just forget the world?
Hello class. It's time to learn a little bit about the object's form by a converging mirror. Let's begin with something at 2F. So let's start now with the first principal ray, going parallel to the principal axis, then through the focal point. Now let's do the second one, going through the focal point, and then parallel to the principal axis. And finally, let's do the third one right through the optical center. They all meet up at 2F to reproduce the same image, except inverted. So now let's do the second one. Let's do an object at F. See what happens. First principal ray, parallel to the principal axis, then goes right through the principal focal point. Second ray, well, you can't really do the second ray because, look, you can't go through this point. So let's go to the third one, optical center. Wait a minute, these are never going to meet, these 2 points here. So that means there's no image. Okay, class, we're going to do one more example for converging, and then we'll get right to the diverging, which could be a lot simpler, depends how you look at it, eh? Am I right, girls, boys? So for a converging mirror, and with the objects at infinity, so way over there, we're going to have the first principal ray zoom parallel right through the focal point, which is located here. And the second one, since it's so far, it's going to do the same thing. And you're going to have a point image, which is a perfect image of what was represented all the way to infinity.
Do the next one. No, go.
Oh, the diverging?
Do the.
So let's do the converging lens right here. Let's draw it out here. And you got to remember that the focal point is different from a converging. Here it is there. Secondary one's on this side instead. You got 2F, and you got 2F. So let's have an object beyond 2F over here. Let's see the first one, right? That's parallel to the principal axis. And it deviates away. But when it deviates away, it's coming back to the principal focal point. Now let's do the second one over here, which will go right through the focal point and then become parallel to the principal axis. And finally, we have the optical center, where it just passes right through. Oh, that's wrong again. That's wrong. I have to restart.
Oh.
Did you think it was right, though?
Actually?
Let me try that again, sir. So the diverging lens is a little different from the converging, where the focal point is on this side. Now you have the secondary focal point over here, 2F prime, 2F over here. Now let's have an object beyond 2F.
First ray, parallel to the principal axis, deviates away from the focal point, secondary, but when you trace back, it goes through the focal point. Now the second one is going to go towards the secondary focal point, but then it's become parallel to the principal axis. And finally we have the optical center, the last third one, so go right through it. And what image is always produced with diverging lenses? Well, it's a small virtual one.
At the point between F and the optical center here. Thanks for learning.
Get out. Yeah, like I was saying, we have a diverging lens here, right? Oh my. And then we have our principal focal point, and on the other side we have our secondary focal point. That's what's different here. We even have a little 2F. Why not? Maybe another one right here. Let's give it a little like. Okay, so let's say now we have our image beyond 2F, okay? So the first principal ray, what it's going to do, you can go dun, 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 dun. It's going to hit the middle here and go boing, right up here, right out of this part, okay? But it's going to trace backwards to the focal point, okay? So there, it hit the focal point. Now, the second principal ray, what it's going to do, it's going to start going towards the focal point, which is here, okay? But once it comes to the middle of the diverging lens, it's going to go that way. So parallel to the principal axis. But it's going to come back again this way. And the third one, as always, goes, that was bad, whistle right through the optical center. Boing, boing. And then you have an image which is right about there. See how they all connect right about there? So that's your image. Your